Good morning to all of you. My name is Megha Rajpoot. I am the assistant professor in BSc CS department, IIMT College of Science and Technology, Greater Noida. So today we learn the topic that is introduction to data structure. So in this presentation, we will cover the following topics like what is data structure, classification of data structure, what is array, stack, queue, and linked list. So what is data structure? Data structure is a particular way of storing and organizing data in the memory of the computer. So these data can be easily retrieved and efficiently utilized in future when it required. So we can say data can be managed in various ways, like the logical or mathematical model for a specific organization of data is known as data structure. Classification of data structure. So we can classify the data structure in the following ways. That is, first is linear data structure. Second is non-linear data structure. Linear data structure further classified in two ways. First is static, and second is dynamic structure. So array will come in a static data structure, and queue, stack, linked lists are present in dynamic data structure. In non-linear data structure, tree and graph are present. So what is linear data structure? In linear data structure, data elements are arranged in sequentially or linear way, where each element is attached to its previous and next adjacent elements. Is called a linear data structure. For examples, array, stacks, queue, linked list, etc. And what is static data structure? As we know, the name static means the fixed size. So we can say static data structure has a fixed memory size. It is easier to access the element in a static data structure. So array is the example of static data structure. So what is dynamic data structure? Dynamic means changeable. So we can say in dynamic data structure, the size is not fixed. It can be randomly updated during the runtime, which may be considered efficient concerning the memory complexity. So what is nonlinear data structure? Nonlinear means not sequentially or non-linearly. So we can say data structure where data elements are not placed sequentially or linearly, or are called nonlinear data structure. In nonlinear data structure, we can't traverse all the elements in a single run only. Trees, graphs are the examples of non-linear data structure. So next topic is array. So what is array? So array are defined as a collection of similar types of data items stored at contiguous memory location. It is one of the simplest data structure where each data elements can be randomly accessed by using its index number. The following diagram are the implementation of array. So next topic is stack. So what is stack? So a stack is a linear data structure that follows the LIFO, means last in first out principle. So stack has only one end, means in a stack the element any elements are stored or delete, means insert or delete only from one end. When the elements are insert in stack, it is called push operation. When the elements are delete from the stack, it is called pop operation. So these push and pop operation are performed only from the single end. It is called the top pointer. So we can say stack is a linear data structure that follows the LIFO, last in first out principle. And we can say stack has one end. It contains only one pointer, that is top pointer, pointing to the topmost element of stack. A stack can be defined as a container. We can say the stack is a container in which insertion and deletion can be done from the one end known as the top of the stack. So these are the some real life examples of stacks, like a stack of coins, stack of plates, and a tennis ball, stacks of books. So these are the examples of stacks. So next is what are the basic operation of stack. Uh, we also explain the push and pop operation, and the next two operation are top and is empty. So these are the operation which are performed in stack data structure. Next topic is what is queue. A queue is a data structure in which whatever comes first will go out first, and it follows the FIFO principle, means first in first out principle. Uh, Queue can also be defined as a list or a collection in which the insertion is done from one end, known as the rear end, or the tail of the queue, whereas the deletion is done from another end, known as the front end or the head of the queue. So, following diagram represent the queue structure. In this, uh, when the elements are delete, it is called DQ. And when the any elements insert in queue from the end, it is called rear end or NQ. So operation performed on queue, these are the following operation which are performed in the queue data structure. First is NQ. NQ means insertion of any elements in a queue. So if we insert any elements in a queue, it is insert from the rear end. And when we delete an element, it is called the DQ operation. And the any elements which we want to delete, it is delete from the front end or the head pointers. Next operation is peek operation. This is the third operation that returns the element which is pointed by the front pointer in the queue but does not delete it. So peak operation are perform the topmost element of the queue. So it is only traverse the topmost elements of the queue. And next operation is queue overflow, means it we can say is full. When queue is full, it perform, it will output the it will return the output as a queue is full. And for underflow, it return the output is queue is empty. When when there is no element in queue, then it will return the output as a queue is empty. And when the queue is full, means lots of elements are inserted in queue, then the output will return as a full. So, what types of queue are? So, there are four types of queue in a linear data structure. First is simple queue or linear queue. Second is circular queue. Third is DQ, and fourth is double-ended queue, or we can say the DQ. So what is simple queue or linear queue? In linear queue, an insertion takes place from one end while the deletion from another end. It strictly follow the FIFO rules. FIFO means first in, first out principle. The major drawback of linear queue is that insertions done from only one end, that is rear end. If the first three elements are deleted from the queue, we cannot insert more elements even though the space is available in a linear queue. So this is the drawback, major drawback of simple queue or linear queue. So reduce or the overcome the disadvantage of the linear queue, we will learn the next type of queue, that is circular queue. So in circular queue, all the nodes are represented as a circular. It is similar to the linear queue, except that the last element of the queue is connected to the first element. Means uh, from the rear end, we can connect the front end, means last node will connect to the first node in a circular way. So it reduce the, or it, we can say it overcome the drawback of the linear queue. So it is similar to the linear queue, except that the last element of the queue is connected to the first element. It is also known as a ring buffer because it is look like a ring as a circular. So we can say it is a ring buffer as all the ends are connected to the another end. So next type of queue is priority queue. It is a special type of queue in which the elements are arranged based on the priority. In this, every element has a priority associated with it. Suppose some elements occur with the same priority, they will be arranged according to the FIFO principle, like first in, first out principle. So next type of queue is DQ. DQ means double-ended queue. In DQ or double-ended queue, insertion and deletion can be done from both ends of the queue, either from the front or rear. It means that we can insert and delete element from both end, that is front and rear end of the queue. DQ can be used as a palindrome checker, means that if we read the string from both ends, then the string would be the same. In the following diagram, we will see the double-ended queue. This is the front end, this is the rear end. We can insert or delete any element from the rear end, or we can insert or delete any elements which we want from the front end. This is the advantage of the DQ, means any elements delete or insert from any end which the user want. The types of DQs, there are two types of DQ. First is input restricted DQ, second is output restricted DQ. So input restricted queue means the name implies in input restricted queue, insertion operation can be performed at only one end, while deletion can be performed from the both end. Input restricted means input done from only one end, but deletion done from the both end. So in this diagram, the input restricted queue are represented. From the rear end, only the deletion operation are performed, and the front end, insertion, deletion, both the operation are performed. Because in we know the in linear queue, any elements which we want to insert, it is insert from the rear end, and the any elements which are from delete, which we want to delete, it is only from the front end. But in DQ, we can insert or delete from the front end. In the case of input restricted DQ, only from the front end insertion and deletion are performed, but from rear end only deletion operation are performed. Second types of DQ is output restricted DQ. As the name it implies, in output restricted DQ, deletion operation can be performed at only one end, same as input restricted DQ. In input restricted DQ, in insertion only from one end, or in output restricted DQ, deletion performed only from the one end. So we can say in output restricted queue, deletion operation can be performed at only from one end, while insertion can be performed from the both end. The diagram will implies the output restricted DQ. So thank you so much for the session. This is the end of the session. Thank you.